Tonight, I'd like to introduce Dana Lepofsky. Dana is joining us from across the border in British Columbia, where she is a professor in the Department of Archaeology at Simon Fraser University. Tonight, Dana will lead us in developing an understanding of habitat management and traditional ecological knowledge of First Peoples in the coastal Pacific Northwest. Born in Norwalk, Connecticut, Dana followed in her father's footsteps and attended the University of Michigan, where she graduated with a degree in archaeology, studying under Robert Ford, a leader in ethnoecology. Not long after, a fateful backpacking trip to the Olympic Peninsula, which has a lot of funny further details, if you read in Nature Trails, was what exposed her to some of the magnificent artwork of the Pacific Coast First Nations and started her on her journey. Dana obtained her master's from the University of British Columbia, where she learned the fundamentals of ethnobotany and ethnoecology while working collaboratively with Indigenous knowledge holders, which was not very common practice in archaeology at the time. Since 1995, Dana has been a professor at Simon Fraser University following completion of her PhD at UC Berkeley. Her work continues to explore the intersection of human culture and natural history, particularly how the First Nations of the Pacific Coast molded and were molded by their environment. Dana has also served as the president of the Society of Ethnobiology and has been the editor-in-chief of the Journal of Ethnobiology since 2013. Most of us listening to the talk tonight reside in the traditional homelands of the Kalapuya people, who employed the use of fire as a common tool for ecosystem management here in the Willamette Valley, sustaining the prairies and oak savannas which define our region. Tonight, we'll learn about a different sort of habitat management in the coastal ecosystems of the Pacific Northwest. I'll quote from Dana's own description of her talk because I really enjoy every word of this description. So in this talk, Dana will describe what we have learned about the development, distribution, age, and ecological workings of clam gardens. We situate this discussion in the broader context of human-clam relationships from the end of the Pleistocene to today. So without further ado, I'd like to welcome Dana Lepofsky.
Thank you. Thank you all. It's really lovely to join you tonight. I have to tell you that I'm a big fan of Eugene. It's one of my favorite places in the States, and it keeps me positive about the US. So that's great. And August, thank you for that lovely introduction. As you all know, I'm calling in from Lepofsky Island, whose traditional name was Hoyatai. It's in the Salish Sea and Northern Coast Salish traditional territories, and several First Nations today have connections to Hoyatai and the many and very deep histories that this island holds in its lands and its seas. So I'm going to share a screen with you. And no. There we go. How's that look?
That looks great.
Okay, awesome. So I want to talk to you tonight about, one of the many kinds of traditional management techniques that First Peoples of this region used to, in this case, produce food sustainably over the generations, and more particularly clams. But as August said very astutely, that fire is another kind of major technique that people use to manage their landscapes and to, again, be able to live in them productively, sustainably through the generations. And so even though we're not going to talk about fire, it's actually one of my other kind of research areas and a favorite topic of mine. So it's just really neat, August, that you made the connection. So I just want to tell you, and I will talk about this again, but it's me that gets the privilege of talking to you guys tonight, but just to remember that the knowledge that I'm sharing with you is very much the knowledge that has been gifted to me by Indigenous elders, by knowledge holders in academia, by community members just across the board over the years. So really this presentation is really by the Clam Garden Network. It's just me who happens to be representing the team tonight. And really, I have just been so blessed in my career by having so many people who are willing to share and trust their knowledge with me. And I just can't imagine kind of doing archaeology without having those teachers along the way. So I'm very, very grateful for all that people have been willing to entrust with me over the years. So this will be a concept really that's familiar to you if you've thought about the use of fire in your region and kind of how we think about our landscapes. And of course, fire was naturally occurring in your region. And so I think it was really easy for settlers to come and kind of miss the footprint, the ecological footprint of Indigenous peoples who've been using, in your case, fire for generations and generations to craft the landscape. And consequently, because it was easy to miss, it was also then easy to kind of make the leap that what settlers were seeing when they arrived in the area was wilderness, free for the taking, especially if when settlers arrived after major smallpox and other disease epidemics, when populations plummeted, then you can imagine the scenario where people could believe that settlers are the first people to come, and that what they're seeing is this wilderness that's just, again, free for the taking. Well, what's really interesting about these two photos here is what you're looking at is anything but wilderness, but you can see why people might have thought that. On the left here, this is actually in Heiltsuk territory up in central British Columbia. And what you're looking at here is a cultivated berry garden on a 6,000-year-old village. There's culturally modified trees, stripped trees, there's root gardens, there's orchards, there's clam gardens in the back here. This landscape is a highly cultivated landscape, anything but a wilderness. And likewise, this beach, and we'll be talking about beaches more. This is, again, a highly cultivated landscape where here you see women are gathering clams, there's size sorting, there's ownership and tenure rules involved. But instead, we've kind of couched these kind of environments, these ecosystems, as wilderness, as wild, as free for the taking. And in doing so, we erase the Indigenous history and the Indigenous presence on the landscape. So, I've seen a lot of change and a lot of awakening and realization of peoples who are recognizing the Indigenous heritage before us and the way that Indigenous peoples have crafted the landscape. And of course, it's just not for BC. This is globally. Indigenous peoples have been living on and with their landscapes for millennia. But the conversation is still very current. And this is an article that came out in January 2020, so 2 years ago, where basically these high-powered scientists use the pollen record and the ancient pollen record, the paleo record, to argue that Indigenous peoples, in fact, did not burn fires in a managed way, and that was actually a misrepresentation of fire management and forest management. So we tried to write a rebuttal to Nature Sustainability, high-ranked journal, saying, there's like volumes of elders and generations of knowledge talking about how people burned those forests to increase nut and fruit species and decrease some other species. And the editors wrote back saying that they didn't consider, basically they only published articles that had data. So the offering of Indigenous knowledge about how people use fire in these forests was not considered data. The use of pollen collected in the lab, I would have said at a completely wrong scale of analysis, was considered data and therefore fair game. So it's still very current kind of discussion, even though we're making headway into kind of changing people's ideas. So what we say is in places like the Central Coast and various places up and down, and it would be true for Oregon too, is that there's this kind of continuum of management practices from mountaintop to ocean floor. And there you can see burning of prescribed fires right there at the top. So these are just a series of practices which my mentor and dear friend Nancy Turner has documented with Indigenous elders throughout the decades. And these are kind of the, if you will, the eco zones represented in this cross section. And what I've done here is put a little plus for all the places where we have ethnographic, anthropological literature documenting the management through these various techniques. So in the subalpine, we have evidence of fire all the way down to meadows and through, based on what knowledge holders have told us. The bolded crosshairs here are the archaeological indications and paleoecological indications of these practices. And the only thing that's really main thing that's important about this is you can see that if we only had archaeological data or only had the oral traditions and the oral knowledge, we would have a less than complete picture of how people were actually managing from mountaintop to ocean floor. So until you consider though, this knowledge, if you can you see my cursor? Can someone tell me? You see me moving around here?
Yeah, I can see it.
Awesome. So you can see where my cursor is here. If we only consider we don't consider people's oral knowledge as data, quote unquote, then we're going to have a very skewed understanding of how people lived with their landscapes in the past. So today we're just going to focus on the ocean and all the various kinds of management techniques that occurred in the ocean, like terracing, clearing, transplanting, selective harvesting, and so on. So this research revolves around this single species, clams. But in fact, my research started by focusing on herring. And herring is what we call a cultural keystone species. It's a species that is so important to people's identity that if you take it away, it changes how people feel about themselves. And this herring is a cultural keystone species, or was until we extirpated it, from Alaska all the way down into California. And it was realized by focusing on one species, it's very clear that you can get at understanding all the other things that are related to this important food. So either herring or clams, it doesn't matter, it's all the same. You can just think of them as a food, or you can think of it as food that's related to kin relations, traditional ecological knowledge, ritual, leadership, economics, all the things that really are embedded in traditional societies around food use. Very different than going to the grocery store, where I don't think, if you picked up, I don't know, a cheese at a grocery store, you would actually have the same matrix. It would look pretty different, I think, generally. So it's something to think about the importance of clams or herring or, these particular foods and how they are kind of really the threads of the fabric that make up the cultural identity of people of this region. And so the sharing of them and the management of them is very central to, again, to people's identity and heritage. So one thing that we do is that we, focusing on these individual species, is create these networks of people. They call it the Herring School in one case and the Clam Garden Network in the other. And basically to look at how do those species, how were they managed, how were they kept, what was the ritual connections of them among people up and down the coast. So by looking at one species, we really have insights into the kind of processes, the cultural, social, and ecological processes up and down the coast. So we're just in the middle of redoing the Clam Garden Network website. I'm super excited by the new logo and the new design, but I still have a bunch of text to write. But the old one is up, and you're welcome to go look at it. So the Clam Garden Network, what it does basically is this is kind of a secret club made of hundreds of people, mostly Indigenous people who are up and down the coast, who are interested in clams and clam management as the focal point of that discussion. If you can imagine, again, that image I showed you of everybody of governance and rights and title and food security and so on. We're conducting research all around the coast, but tonight we're just going to focus mostly, not entirely, on Quadro Island here in the northern Salish Sea. Here, by the way, is Lepofsky Island, if you can see where I'm calling in from, right down here, also in the Salish Sea. And as I mentioned, this is kind of the Clam Garden Network, is this kind of loose collaboration of people, many people who are interested in clams in this way. And so again, just a reminder that it's me talking to you, but I want you to imagine the several hundreds of people who are involved in the research up and down the coast. So in order to understand clam use, clam management over time, we use various kinds of innovative methods. So we're really interested in getting at all those little pluses that I showed you on that diagram. And one of the ways, of course, is to talk to traditional knowledge holders. And by talking to traditional knowledge holders up and down the coast, we've learned a lot about clams and clam management. TEK is traditional ecological knowledge. We've learned how people have managed their beaches by tilling them, by adding sediment, by size selecting, by picking up certain clams and putting them back if they were too small, by carefully timing when the harvest happened, and by restricting who can happen, when it can happen, and where it can happen. We've learned a lot about how clams were harvested and processed. We've learned, of course, about changes in harvesting practices today and dramatic changes in local ecology. We've also learned about the importance of clam digging to solidify family and other social relations. So, you can imagine if any of you have dug clams, as anyone in the group, I can't see your faces, but you would know, or picked berries together, that when your hands are busy, it's like if you're, well, Charlene, because you're a weaver, spinner, when your hands are busy, you chat with people around you. It's a really wonderful time for sharing knowledge and closeness. So we know that traditional clam digging was a time when the elder generation and the kiddos got together to dig clams. And in that time, elders were teaching kiddos all kinds of rules and regulations and the right way to be. So once you start restricting people from doing that, you've lost this major conduit of knowledge from across generations that were central to people's identity for generations. We learned also, of course, about how people harvested clams in special places, and of course, including clam gardens. So what the heck are clam gardens? What do we mean by these things? So I'm sorry to say we have yet to discover clam gardens in Oregon. I wouldn't be surprised if they're there. But we just haven't found them. We think we've found one in Washington, but most of them occur in British Columbia and some into Southeast Alaska. And what they are, as you can see, my cursor, is you get this rock wall that is formed by carrying or rolling rocks down the beach to form a terrace. Through time, the sediment fills in behind the rock wall and produces this pancake flat terrace like you see here. What you're looking at is exposed only at the lowest low tide. So the rock wall is built at the very low tide of the year. Okay, which, as we'll talk about in a sec, makes doing field work a bit challenging. So people built these rock walls in different kinds of contexts, and this has been really important for us to understand this particular kind of management technique, this cultivation, if you will, of the beaches. We understand now that people built rock walls on soft sediment beaches, that is, beaches that were already sandy, that had rocks on them. You can see here, you can see how it's cleared. They taken the rocks and cleared them off this whole area, made this rock wall. This is fantastic. Look at this. They even made a little space here for bringing your canoe into the rock wall. This is us doing field work. This is a drone photograph. But not only did they build rock walls on beaches that already had sand and gravels where clams could flourish, they built them on bedrock shells that had no sand or gravel before. So in cases like this, they're 100% creating habitat where there was none before. They build a rock wall. This is bedrock underneath. Sediment accumulates behind it, and clams start to flourish. Similarly, people built rock walls on these narrow, steep, eroding banks. So this is all, you can't see as well, but trust me here that these are all kind of cobbly, rubbly slopes, like small slopes. And people basically pushed out the rocks and created these long, skinny clam garden walls. All this is to create garden space, to create food, to feed people sustainably. So this is what it looks like in cross section, just to help you visualize it a little further. This is what the natural beach looks like. Here is butter clam and little neck clam and their happy place. Little neck clams are the green line here and butter clams are the yellow. Butter clams like to go burrow down a little further than the little neck, This is what it looks like at low tide and high tide. High tide, the beach is completely covered up. And at low tide, you just get this little bit of, the beach is at low tide, the beach is quite exposed. But then as you see, as the tide rises, you get less and less of the beach showing. That's the natural beach. You build a wall, however, through time, it builds up with sediment. And what you've done is you've taken what was that habitat for the little necks and butter clams, now buried, hey, under that flat terrace, into this zone here. And you can see this is the new beach surface. What's happened is you've increased the time where you can get clams. So here at a 1.3 meter tide, you still have full access to the butter clam and the little neck habitat. So you've increased manyfold your accessibility to those clams, okay? So in this case, we may have not increased the area, but we've increased the accessibility. However, if you built it on bedrock, not only increased accessibility, you've increased the area because there was no beach before. So you can see it's a really, really viable way to create garden space and to create your access to garden space. Now, as we'll talk about later, not only are you creating access or creating area in the case of bedrock, but we'll also increase the productivity because in doing this, people have actually created much better sediment, much better garden soil than you could often get naturally. So we'll talk about that in a little bit. So this is where Quadra Island is, again, to show you on a map. Beautiful, beautiful area here. This is Canish and Wyatt Bay. If any of you know Quadra Island, you know that it's a really funny little shaped island. It's the very northern part of it. And there's this very narrow pass between Canish and Wyatt Bay, which you can walk through. And we spent quite a bit of time there recording clam gardens. These blue dots are clam gardens. So what you can see is that in Canish and Wyatt Bay, basically every bit of beach that could be transformed into a clam garden has been. So that is every bit of bedrock that's flat, every bit of scree slope, every bit of natural beach has a clam garden on it. The yellow dots are village sites. You can see this area is very, very densely populated. And the red dots, red stars, you don't need to worry about, but those are our sampling sites. So you can see already where we're going to go with this. A lot of people living here, a lot of clam gardens, a lot of gardening going on, a really, really good way to feed the people. This is just to show you some of the beautiful clam gardens in Quadra Island. You saw this one here in the lower left from the air. That's us doing field work. Can you guys see the white caps behind our boat? That was a crazy day. Oh my God, I didn't think we were going to get off the island there, but we did. This is a beautiful, this one in the upper right, you can see from the air photo. Can you see this is just a Google Earth image? Oh no, actually, I'm sorry, this is our drone image, but it shows up in Google Earth. This dark line here, that's all clam garden wall. Here, this island, that's all clam garden wall. Here's another wall. Here's another wall. Here's another wall. Same here in this lower right. Can you see that? Wall. All created, 100% created. Okay. So remember that I said that clam gardens are built to the very lowest low tide. Well, what that means is that they're only visible about 5 days, 3 hours a day in May, June, July, and a little bit of August. Those are the only daylight hours you actually can see a clam garden, which is one of the reasons that people didn't, well, another reason they didn't talk to Indigenous people, but why people just haven't seen clam gardens is because mostly they're buried underwater. This is what it looks like actually being on a clam garden and trying to do field work on a clam garden in that 3-hour window, which is usually, unfortunately, very early in the morning. I love that video. I could watch that video 50 times in a row because that is what our life is like. I swear. It's like now you see it, now you don't. It's incredible. Anyway, it's quite neat because it really does feel like that because when you're doing field work, it's like, oh my God, all of a sudden the tide's coming in again. So I just want to check the time because I don't want to keep you guys. Okay, we're good. So we asked, we can ask, and we are asking a bunch of different kinds of questions of clam gardens. And many of these questions were inspired by working with our Indigenous colleagues and teachers who have told us that things like clam gardens create more habitat and they're more productive and that they, they're very old. So we asked questions that really were sparked by conversations we've had with people that you can see here. And we'll go through each of these and talk about some of the methods that we use to understand them. So first question is, how much habitat was created? And I alluded to this before, that remember that in this image on the right, this is one of those beaches that was created entirely by the rolling of the rocks down and the filling of the sediment to create this beach. This was bedrock before. So it was not clam garden before, it was just rock. So in Quadra, my friend, who knows a lot about aerial photography and mapping, basically calculated that there's 15 kilometers of walls in those two bays that I showed you. About 1/3 of the shoreline is in clam gardens, making over about 11 hectares of clam habitat. That's a lot of food production to feed those people. Furthermore, about 1/3 of them are on bedrock with no clam garden, no clam habitat before. So we're talking, that's a lot of, again, food production in general, but also totally created from scratch where there was nothing there before. We can ask too then, okay, how productive are clam gardens today and what influences their growth? Elders tell us they're more productive. Are they? Let's see. This is actually my former student, Julia Jackley, who is from Oregon, who I just spoke to, and Anne Solomon, who's a marine ecologist extraordinaire and one of my main partners in crime. Anne and her students have done surveys and all kinds of experiments kind of mimicking clam garden habitat inside clam gardens, outside clam gardens, and basically have evaluated how productive are they today, clam gardens, compared to beaches that do not have rock walls. Okay. So I just want to tell you that these are experiments are happening today when people are not tending them as much as they were in the past. So just even asking today in a kind of less tended environment, how productive are clam garden beaches? Well, we find that clam gardens are flatter and they kind of encourage clam habitat. But we find that they have greater productivity in terms of biomass and density, especially the young ones. And this is really important because you want to have a healthy population of young ones to have a sustainable harvest, right? And the reason is that the clams are growing faster and they're surviving better, again, especially the young ones in clam gardens than not. And Anne and her team has calculated that they're up to 300% more productive, clam gardens are, than non-walled beaches today. That's enormous when you're thinking about feeding people. So it wasn't enough for Anne to think about kind of yeah, that clams were doing better. She wanted to know why, being an ecologist. And Natasha here, with this fabulous experiment, basically of kind of creating fake clam gardens and doing measurements of various kinds of things to say, what is better about clam gardens? Why are they more productive? And they found a bunch of things. They found that there's greater water flow, there's more gravels, and there's less silts, all of which really are things that clams love. But especially important to clam survival are these two things. They stabilize temperatures, clam gardens do, because they seem to be less cold in the winter and less hot in the summer. So during our summer heat domes, Anne was doing surveys in her wetsuit, and she could feel the temperature drop when she started swimming over the clam garden. So what does this mean for management going forward? This is probably a really critical kind of result. Furthermore, clam gardens are made of broken shell, mostly broken barnacle. The wave action on the walls create this very carbon-rich sediment. As our oceans become more and more acidified, the fact that we have these really carbon-enriched gardens for growing clams is also going to be really critical going forward. But these two reasons, especially the stabilizing the temperatures, less cold in the winter, less hot in the summer, and the increase in organic carbon are critical for making clam gardens more productive. So we can ask, okay, great, that's how productive they are today, but what about in the past when they're actually being actively used? So in comes the archaeology. The first thing everybody wants to know about clam gardens is how old are they? And that was actually took us a surprising amount of time to figure out how old they are and how old are they. So my friend Nicole Smith and I, we dug a bunch of trenches into clam gardens. And what we're looking for, we reasoned that we would be able to find clams that were on the surface of the beach, hey, that when people rolled the rocks down the beach or carried the rocks down the beach toward the wall, they would have put the rocks on top of some clams. In doing so, killing those clams, which is great for us, because then if we get a radiocarbon date for that clam, we can measure when did that clam die? Well, that clam died when it had a rock wall put on top of it. So basically, we just trenched the walls to find clams that look like they died with the rock wall. We also dug into the terraces themselves and found buried clams that we could date. And also, we dismantled some of the walls, we put them all back, to find barnacle scars. So if people are taking rocks that have barnacles on them and they're rolling them down or placing them on the wall, they put them in the muck, they can sit there with that little barnacle scar for thousands of years until we come along and scrape off the barnacle and get a date on that wall. So what do we learn? We learned that they're very complex histories, but the clam gardens are being built at least 4,000 years ago. And so now we know in a couple different places on the coast. So that's a really cool thing that 4,000 years ago, the indigenous peoples of BC, probably Washington, and Alaska at least, are cultivating clams in clam gardens. What we see though is that these are very, very kind of complex living features, and that there's a lot of radiocarbon dates kind of all in one feature because, of course, people are rolling the rocks and refurbishing these gardens all the time, especially in our area as sea level is changing through time. It's going down here and it's going up in other places. People are constantly having to refurbish these rocks so that they're always at the lowest low tide. So this just gives you an idea of, this one's 4,000 years, 2,600, 3,000 years. It's very, very complex histories associated with these walls. We're working on this alternative way to date clam gardens, because as you can imagine, it's pretty labor intensive to always dig them and to hope you find a shell that's buried or a barnacle. We also are actually in places where we have really, really detailed sea level curves. So remember I mentioned in Quadra, sea level has been going down since the beginning of the Holocene, the end of the Pleistocene. And we know exactly where sea level was at 4,000 years ago, and 3,000, 2,000, 1,000. So we could say if people are building walls right at the lowest low tide of 4,000 years ago, right, and sea level is going down and down, that wall that was at sea level 4,000 years ago is now stranded high and dry. And we see all these walls that are way above clam habitat today. That's the reason. They're really old. So my friend Keith Holmes did this really cool flyover, and he actually has heights, wall heights of every segment of Clam Garden in Quadra. And what we've been able to do for the soft sediment beaches, for the bedrock beaches, and for the scree slope beaches, we've been able to say how old are those walls based on their wall height. Because this wall up here, that's 2.5 meters above current sea level, could not be used 500 years ago. No clam in its right mind could survive there today. So you can see we can start actually dating and figuring out, based on not excavating, but based on these air surveys, of how many clam gardens are being built through time. And we're just figuring out kind of what this means in terms of settlement patterns, but this is really robust. This is like 800 and some odd data points. And we can start to say how many walls were built between 4,000, 3,000, 3,000, 2,000, and so on. And how does this compare to what we know about things like, how many villages were constructed during that time? So this has not been published yet. It's all new stuff. We know that, as I mentioned, that clam gardens today are much more productive than non-walled beaches. But of course, what we really want to know, well, we want to know that too, because we want to actually use this kind of knowledge going forward. But we also want to know how productive were those gardens in the past. Because we want to know how well did it feed the people. We know that there was a lot of gardens. We have an idea of when they built them. We had to do with the idea of where they are in relation to settlements. But we're also really interested in how fat and happy were they? What influenced their growth? The same way that we asked about it from modern experiments. So to figure that out, we basically looked at clam growth, and we dug clams from the clam garden wall, from in the terrace itself, and from the shell midden behind some of these sites. So these would be clams that in the shell midden that people collected from the clam garden when it was active and brought them here and deposited them. And just as a little spoiler alert, you can see here in the lower right, the great variation in size of clams that we see through time, which reflects how fat and happy those clams are, reflects their growing conditions. So to understand this further, we collected the clams from those different places, and we basically sliced through them and then look at the growth rings. And we can ask, just like we did with the modern experiments, how fast did the clams grow? We can ask how fast did they grow when they were just little babies, or how fast did they grow later in life? And that gives us a good idea of the growing conditions. And we can ask then, did they grow faster? Did they grow bigger? Did they live longer in clam gardens versus non-walled beaches in the past? Okay, you with me? So I can't see if you say, I'm just going to believe you're going to nod. Yes, Dana, I get this. No problem. So what we did is we collected clams from those different kind of contexts. And we were able, just miraculously, you guys, it was completely luck of the draw. We didn't know what we were doing, honestly, but we were able to gather clams that dated from 11,000 years ago all the way to living clams today. So, and we were able to group them into these 7 time periods that were pre-clam garden, during clam gardens, when they were actually taking the clams from the clam garden and putting in the middens, and then the early historic period when population started to decline, and today. So we can ask, how fat and happy were those clams at various times in the past? What we see, and you guys just don't, this is basically size, how big are the clams when they died? Because the bigger the clam is that died means the faster they grew, it means the healthier they are, yeah? and the better the growing conditions. So you can think of people today, you can think of people who have a poor diet or impoverished. They're going to struggle when they're kiddos. They're going to be smaller when they're older, and they might die sooner. Yeah. So just follow the red line. You don't need to worry about the details, except that at 11,000 years ago, the clams are teeny. And that's kind of what's shown here in the upper right-hand corner. And then they start increasing in time. Right after the Pleistocene, they get bigger. Around 4,000, 3,000 years ago, they get really big. But unfortunately, here, these are our clams that come from the midden, and we can't look at how big they are because people are harvesting them. These are clams that died in place. People weren't harvesting them. There weren't many people on the landscape. These clams are clams that died because people harvested them. So we don't know how big from their size that they would have gotten if people hadn't eaten them. Okay, so we'll come back to that. And then we can just look here. These are clams that we harvested in the beach today. So they got to live to their full size here. And you can see there's a big drop in the early historic period in the size of the clams. So let's fill in this middle and see what the whole trajectory is like. You don't need to understand what we did. Just trust me that basically what we were able to do in those clams that come from the midden is you could slice them and look at how fast they grew when they were little. And you can model then as how big they would have gotten if people haven't harvested them. Remember, just like looking at a kiddo, because how well nourished they are when they're little and how fast they grow when they're little, when they're young, will determine really your ultimate height. So we're able to take those clams that were from the midden and basically slice them and count their rings and say, okay, how fast were they growing? And then we can project, if people haven't harvested them, how big would they've gotten. Okay. And what that allowed us to do is basically fill in that middle bit and say, what's happening to the size of clams through time? And what we see is this really lovely little pattern. Clams at the end of the Pleistocene are really small. They get bigger and bigger, and then they stabilize in size. And then the early historic period, and today they're small again. What's going on? Well, around 4,000 years ago, when they get big, guess what's happening? That's when clam gardens come into the scene. So can we say that every clam that we looked at got big because it was cultivated in a clam garden? We can't. But there's very compelling evidence to me that that's what's going on. And what's happening here where they're declining in size? Well, we have a decline in human populations, a decline in clam gardens, a decline in all those traditional management techniques that we talked about that people did to help clams be more robust. So what this says to me is that people have been living sustainably, productively with those clams for many thousands of years. They're feeding lots of people, but it was only in recent times with the loss of traditional resource and environmental management, and declines in habitat that we see this very strong drop in size. Yeah. This is really important to think about, this idea of a shifting baseline. That means that the clams that we're seeing today, which we said we were already better in clam gardens than non-walled beaches using our experiments, yeah, are actually much smaller than the best clam sizes that were happening when people were actively managing the landscape. So it's really compelling evidence, it seems to me, that, kind of going back to these traditional management practices are essential for food security, food sovereignty, but also for reconnecting and restoring connections to place and to heritage. And consequently, Indigenous peoples up and down the coast are taking the lead on restoring clam gardens. And in this case here in the Gulf Islands, a fabulous project run by the Wasanich and Hunkaminam Treaty Group and the Gulf Island Park System. They're actually here, sea level has been coming up through time, not dropping like in Quadra. So people are reconstructing the beach and they had to build a new wall. If you can see in the after, that is at the current sea level. And they're doing all kinds of experiments to measure how well are clams doing in these newly rebuilt clam gardens. But more important than the food is all the connections and the excitement and the revitalization, the reconnection to heritage through clams. Clam gardens to me are all about reconciliation, a big word, a big process, an important process. We're working to get clam gardens in the schools. I just had a conversation today with the woman who heads education in British Columbia about bringing this kind of information even more into the school systems. But we've made it into the K-9 system in BC, talking about clam gardens. We're involved in this book. If you want to visit a sea garden, beautiful book by Kay Wiseman and illustrated by Roy Henry Vickers that we kind of facilitated through the Clam Garden Network, all about getting the word out about clam gardens. We're currently running this fabulous webinar series that has hundreds of people signing in up and down the coast, mostly Indigenous people. It's co-run by Western scientists and Indigenous knowledge holders to talk about kind of the clams and all those myriad ways that are important. And if you remember that original diagram that I showed you with clams in the middle and talking about governance and rights and title and food security and so on, we're covering all these in the webinar. And it's just been a humbling, beautiful, fantastic experience. So what does this all mean? Why is this all important? You know, just thinking about kind of how we can take the knowledge, this age-old knowledge, in this case, 4 millennial-old knowledge, and bring it forward in today. And there's obviously lots of really critical contexts where we can apply this knowledge to our changing oceans. To do so really involves, I think, recognizing that there are these long-term connections among ecological systems and social systems, and that whole idea of wilderness just doesn't fly. And then once you start recognizing that, you realize that there's a lot about the past, the innovations of the past that can inform the present. I think this is really all about creating ecologically sustainable conservation strategies. There's a lot to be learned here, and really using not just ecologically sustainable, but culturally sustainable conservation strategies, because we're talking really here about not just better science, but more socially just science. And that's it. This actually is a 10,000-year-old clam from up in the Central Coast. And that's all. Thank you.
Thank you, Dana. Let's all unmute and give a round of applause.
Fantastic.
Thank you. That was really wonderful. I get the privilege of having the first question. And this time I'm not cheating. I actually entered it in the chat first. So, so I'm curious. I was actually thinking before your talk, I was just thinking a bit about clam gardens and curious if any exist in Oregon. And then after you said that, you know, we haven't really found any in Oregon, I'm just wondering if that's partly because our beaches are a bit different, and that, you know, the Oregon coast beaches tend to already be quite a bit sandy, a lot less rocky, but even more so, they're not island systems where, you know, I think here we associate our clams predominantly with estuarine systems. And we have so many rivers flowing out into the ocean along Oregon, whereas, you know, in these little islands, you don't get that. Is that partly what's going on there? It seems like if they did have clam gardens, they'd be more productive from what you're saying, but.
Well, yeah. So that's right. The Oregon coast has always been different. Like Oregon archaeology is different. Oregon, you know, the natural history is different, you know, of course. You know, the truth is that is true, geomorphologically and ecologically different. But, you know, if I had to guess, I would bet that there was a clam garden tucked away somewhere. This was so widespread that if there is the right geomorphological conditions, people would have tried it because they were, you know, there was so much trade and, you know, there's Oregon obsidians up in BC all the time. Like there's like major associations going on. It's not going to be the same kind of concentration because of all those reasons you say. but did it never happen? That seems unlikely, just because it seems like there would be a pocket that people would have tried it.
But be a place to look.
But yeah, so you know the kind of beaches to look for, like little kind of nooks and cranny beaches. They want good flow. Those ucky mucky beaches that my kids used to tell when they're little, like the really sandy beaches that cockles love and stuff. You're not going to find a clam garden there. That is totally true. But and a lot of the beaches in Oregon are too exposed. They're way too exposed. So all those things are true. But it's just really curious to me that like in Washington, the only recorded clam garden in the ethnographic record comes from Washington, from the San Juans or north of there. And we can't find it. We can't find it at all. Like that foreshore is so mucked up that we can't find the clam garden. We think, the collective, like not me, they think accidentally, just 2 weeks ago, someone found a clam garden because they were out at the low tide at the right beach in one of the San Juan Islands, not the one that was recorded ethnographically. So it seems like there were more. There must have been more. And we're not finding them in Washington. So I expect there's even less originally in Oregon, but you can't prove me wrong until we'll never know. But I would just be surprised if no one played with the idea.
Yeah.
Yeah.
Thank you. Our next question comes from Carol Milliman. Carol, feel free to jump in. Maybe. I'll go ahead and ask it. Carol's wondering, how long do clams live on average? And I'm assuming that varies by species quite a bit.
Yeah, it does. And I'm actually, mostly they're not left to die. We harvest them. But, just looking at the age graphs, and there are two different, it does have those species, but for the butter clams that we looked at, the ones that were growing the best, like, in the clam gardens in the past, were living till about 25 years or something like that, 20 years. But most of them were truncate, most of them around 12 years, it looks like.
And the next question is from Margaret Essenberg.
Yeah, that's a great question.
Yes, would you discuss how the gardens, the walls moderate the temperatures?
Yeah, excellent. Thank you for calling me on that. I didn't explain that very well. And so basically, if you can imagine a wall and water is getting trapped behind them, because they're holding water in, so they're slower to drain than a normal beach because they have this flat surface and they have that wall. And it seems that that wall, because it's retaining water a little bit, and is cooler than than the non-wall beaches that have more of a slope and are draining quicker. In the winter, I actually don't know the mechanism of why it's moderated, and I should know it because I'm on that paper, but I actually don't know if they know why in the winter it's moderated. But I think it's actually probably the same thing. It's probably because there's more water, so they're less likely to freeze, right? Yeah. You can get a lot of die off. You see this in the Central Coast where beaches are just covered with dead shells. So in a clam garden, because there's more water and it's salty, it's less likely to freeze than in an area that's, again, drained. So we have really good data on it, less cold in the winter and less warm in the summer. So I think it has to do with water retention, a lot of it, and porosity too. The porosity of the sediment's different too. So good question. Yeah.
Thanks. The next question is from Kim.
So back to the question about clam gardens in Oregon, I was just wondering if it makes sense to me that the abundance of food in our area might have influenced the development of such a thing. And then isn't it something that could be develop now and use to help feed people?
Yeah. Well, what's really neat. So first of all, just in terms of the abundance, I would say that definitely the abundance in Oregon, but also abundant here in the same way, but we're feeding lots of people, tens of thousands of people, like way more people, right? I mean, outside of the cities, there's way more people in the countrysides in the past. Like if you think of those settlements, they had a couple hundred people. Remember how many dots there were on the map? There were a lot of them. So yes, abundant, but not abundant enough. We know,
people.
well, we know that people can we know what people can do in terms of destroying a food source. So I would say that in Oregon, whether or not there's clam gardens, I was just speculating that there was one or two tucked away somewhere or were in the past. We know that people were managing, as we started off this talk, managing for food. Like that's what fire management was all about in Oregon, like those prairies and other things. People are having to manage. So what they manage, they're working with the environment they have. But I don't think it was a food abundance, absolutely, because the food abundance was actually created by people managing. But as for today, yeah, I think there's going to be lessons to learn whether there's a clam garden in the past there or not, because for instance, the Swinomish tribe in Washington, they're doing this really amazing clam garden restoration project where they looked for a suitable beach culturally and ecologically. They didn't care if it had a rock wall archaeologically or not. They were just looking for a suitable beach that the community could start building a clam garden on and have it be a community-based project for food sustainability and sovereignty. So the beach they chose had all the right ecological and geomorphological requirements, but it had no clam garden on it, with a rock wall, but they put one on there. It's awesome. I love it.
Thank you. The next one, okay, so we've got two that are somewhat related. So Margaret Essenberg has another question about sea levels. And then after that one, we've got another related question about sea level. So Margaret, go ahead.
Yeah.
Mine was, as climate change causes sea levels to rise, will these rock gardens be adjusted by making them higher, or will they be moved further from the current low tide line
Yeah.
with new ones?
Brilliant question. Well, what we see, we've seen, it's harder for us to know what people did in the scenarios where sea level has risen in the past, like the restoration project I showed you, because it requires diving to actually look underneath this to excavate. It's a whole other thing to excavate one of those. But my guess is that people would just be rolling rocks down on the land side of the wall and building up on the land side. And that's what we see in the one that I showed you that's 4,000 years old, actually. But sea has come up on it. So it's just got this huge, like tail, if you will, that goes out into the ocean. And people just kept building on the land side. Because see what I mean? So they just rolled rocks and they just built, so they built up, but also landward. So your question is bang on. It's both. It's both of those things. Yeah.
Okay, thank you.
Yeah.
The next question related is from Amy.
Yeah, so I was just wondering what was going on with the sea level in British Columbia, because my understanding, which I am not an archaeologist, but my understanding is that the sea level in Oregon has been coming up basically since the glaciers melted, and the sea level has been rising and covering up the archaeological sites that we would expect to find out on the coast that we don't find because we assume they're 5 miles out underwater.
Girl.
But it sounds like in British Columbia, you had places where the sea level has risen and other places where the sea level has fallen.
Yes. Yeah. So Amy, if you're confused, it's because it is so confusing. So when I was a grad student back in the Pleistocene, it was like, we thought, just like in Oregon, after the Pleistocene ice melted and sea level went up. Easy peasy. Well, no, God, no. It was so nice in those days. So you guys have it easy because you weren't glaciated. So you don't have that whole compression of the land and the rebound and this whole thing that we have. You don't have, you don't have plates that are snapping against each other. So the east side of Vancouver Island is lower than it used to be because it's under a plate, where the west side is higher than it used to be. And you have local tectonic activity. So it's a mess. So remember those two bays I showed you? Yeah. In general, in Northern Quadra Island, because the sea level is dropping in general. I'm not talking about climate change patterns that mess everything up again. Dropping, except in it's just dropping gradually, except in the bay to the east, there was some major tectonic activity, we think around 2,000 years ago, that basically shook all the clam gardens and made them sink even further. So it totally messed everything up. So we're trying to use those wall heights to figure out, based on sea level, how old they are. We have to throw out that entire bay because of the stupid tectonic event, the earthquake.
Right. Okay.
Messed up the data.
More sense. Yeah.
It doesn't make sense, but it's complicated.
It is very complicated. So
Yeah.
thank you.
It's cool.
Yeah.
Thank you. That was a great answer. Let's see, the next one's from Sharon.
Yeah, when you were talking about clam size and it kind of leveling out at that one point, I was wondering, when you look at the clams you're collecting from the middens, are they kind of more uniform in size, indicating that it was sort of like an agricultural product? And
my
when
God.
it reached a certain size, they were like, yep, this one we eat.
That's, you guys, these questions. Oh my God, incredible. So Sharon, yes, thank you so much for that question. So the thing about clams, if they're left and they're happy, like in a clam garden, they'll just keep growing until they'll live long and they're fat and they're big. But if you're going to harvest them, you have to make just certain decision rules, which is a kind of management decision about how big your clams are going to be. So you nailed it. What we see is that in general, people are harvesting them with a particular range, and they're not taking the very small ones. They're not never taking small ones because they're probably taking basket loads, but in general, they're taking a particular range of sizes that suggests that the small ones are going back. Now, whether it's because we can't say archaeologically, is it because there's a management prescription to return the small ones so they can get bigger, or it's because they say, who wants to eat those? It doesn't really matter. The effect is that it's a sustainable harvest. So really, really good question. Yeah.
All right, and the next one, more of a philosophical question, but a really good one, is from John.
So, Dana, do you have any ideas about whether the oral traditions that you were talking about in the beginning will be or are more acceptable by the scientific community now than they were in the past? And if not, is there a way, you see ways to increase their what should you say, their acceptance?
Yeah. I would say there's definitely been a shift over the course of my career, hands down. There's been a shift in the last 10 years. There's been a shift in the last 5 years.
Wow.
So definitely, frankly, it took a bunch of people retiring. Get them out. So, I just think there's more of a general awareness, but is it across the board, really? I got this stunningly racist email right before I came. I was so sorry I opened it, and I'm so glad you guys have just put balance into my life about kind of they basically said that to argue for preserving Indigenous heritage was racist, meaning racist to white people. Sharon, this is an Islander that wrote me this. So yeah, so I would say that it's changing. Is it changed? No. And how to change? Through education. That's the only way, like to education and talking to your politicians. One of the reasons I love living in Canada is you can be a big fish in a little pond. Like, it's really cool that I get to talk to the Assistant Deputy Minister of Education to talk about archaeology and clam gardens. Like, that's cool. You couldn't do that in the States, right? Or not, it's not as easy.
But in-
Education,
But in,
critical.
but in the scientific community, do you see an increase in acceptance?
Definitely. Like some of these papers that I've gotten accepted into, like, their ecology journals, and they want to see these papers. So there's been a definite shift. But it's not 100%, and it's so far not over. But definitely, I think there's in some sectors definitely reason for hope. Yeah.
Thank you.
Yeah, thank you. I'd agree, a big change, particularly in the last 10 years too, locally here. The next one, I think it's sort of a joke from Steve Paulson, wondering if they make a good chowder. But curious how they were eaten.
It's actually from Jill Paulson.
Okay.
And so my question is broader than that, but that was my lead off. And that is, how did they prepare the clams? How did they eat them? What was the preferred methods? Were they dried and used as trade for some of that obsidian?
Yeah, well, you answered all the questions. There you go. That's it. They were roasted and dried. They were steamed. And some of it they put like on a stick to roast them. Interestingly, one of my teachers, Chief Quaxistala, told me that they would do all the roasting on the beach near the clam garden next to this big rock. And he could show me the rock that he used to roast all his clams. There's little on these sticks. And then they would definitely been traded 100%. And then the clams themselves, the shells, were brought up into the land and then used as construction fill to make those beautiful flat foundations on which people built their houses, because they drain really well. So really valuable, really valuable food.
Thank you. And then a really good question from Nancy. Obviously, these clam gardens had impacts on other species. So Nancy, if you want to unmute yourself.
Actually Kate, but what were the impacts of clam gardens on other species, and were there any negative impacts?
That's such an astute question, Nancy. The truth is we don't really know. And I suspect there's winners and losers. It's not all, when you start mucking with ecosystems, even at the micro scale that mimics natural processes, because these are just mimicking natural processes, right? That's what traditional ecological knowledge is really all about. There could be easily some losers. I don't know if they're like sea worms and things like that didn't like having the sediment change. That's possible, but we have no way of measuring that. Other kind of positive impacts is the creating of these rock walls. In fact, some nations don't want to call them clam gardens. Well, I should tell you, clam gardens is obviously the English word. There were traditional names for them like Lochiwe and Wachtwatham and so on. But in English, some nations want to call them sea gardens because they're actually creating reefs. They're creating ecosystems that attracted octopus, sea cucumber, all kinds of terrestrial critters like the raccoons that took all our coolers off to the low tide and we never saw them again, deer, all these things, seabirds are all being attracted by that to the really lush ecosystem, because these are ecosystems are being created by the building of these clam gardens. But who are the losers? Don't know. Like maybe they're, I've wondered about like on those bedrock shelves, like maybe there's some microorganisms that were living on the bedrock shelves. We can never know, but I always try to think about that. I think it's really important to recognize that once you start mucking with, age-old processes, that there could be losers in the scenario. But in general, they seem pretty, they seem well, they're much gentler, of course, than kind of logging up slope and having all the sediment kind of coming down the slope onto the beaches today, which is what we see when we excavate them. And most of our beaches are smothered because of all the logging up slope, and that most of those silty beaches that we have in BC, in fact, aren't silty beaches. They're just silty because of the logging. Like, I didn't know that, but if you go 30 centimeters things, building clam gardens were small in terms of ecosystem shifts because they're kind of mimicking more natural processes at a very kind of fine scale. But it's a very astute question. I'm glad you asked it.
Great, well, thank you. Next question, I guess I don't know if you want to ask that in person, Ross, or if that's just question, but asking if he can email you with some botanical questions.
Of course he can. Yeah, of course.
And I don't know if you want to put your email in the chat
or
or anything, or email him
sure.
or message him directly, or.
No, I don't care. It's embarrassingly easy to find me on internet. So
it's true.
It's really like
I track you down really easily.
Yeah, no, it's not hard.
All right. And there's some great comments in the chat too. So if you haven't looked through that yet, definitely recommend looking through. But unless anybody has any other questions, I think that about wraps it up.
I have one. Just, I would like to know whether any work has been done in the Western Pacific, in Eastern Russia, Kamchatka Peninsula, because I would think that if they're over here, they might be over there.
Yeah, I think so too. And I'm not convinced that they're not. But when I started in this journey, I was sure they were everywhere, like, to be honest. Like, and so I wrote, I struggled through kind of emailing with colleagues in Japan because they have huge shell middens, and no one else is talking about them. There's other kinds of cultivation methods. Remember, this is just the wall. And what's cool about the wall is that they're undeniable to naysayers, right? But embedded in these walls are the tilling, the size selection, the tenure, all the things that you can't see archaeologically, but they're there. So clam cultivation, and we start looking into the literature, bivalve cultivation is worldwide because for millennia, because people relied on them. So I found this fabulous painting of Tokyo Bay. Like, that was Tokyo Bay, full of middens. Like, and there was pictures of women digging with digging sticks of clams in the bay. Like, it just made me weep. Like, this Tokyo Bay is not that now. So yeah, so amazing. So I think that I thought that there was going to be other kinds of clam gardens elsewhere. It may be particular to these species. We just don't know because it's not our water flow. I don't know. So it's a long answer to say not yet in Kamchatka, but
okay.
I don't know. Yeah.
All right. Well, thank you. Let's give one more round of applause. It was really wonderful.
Thank you, Dana.
Thank you so much.